So now I am considering the subtraction of the two vectors. So this is your A vector and this is your B vector. And if they are making angle theta, then what is the resultant of the two vectors? It is very simple. If O is the point, OA is A vector, OB is B vector, and see, if we consider the parallelogram as an adjacent side of this A vector and B vector, so resultant between them is equal to R. R is equal to, you can easily write A plus B. So this is your parallelogram, law of vector addition that I had discussed, right? But see, subtraction of the two vectors. If you want to subtract B vector from A vector, so this is A minus B, and I am writing here this vector is your R prime vector. So in this situation, what we will do, that is equal to R prime vector is equal to A vector plus, this is minus, so I am writing like this way, minus of B. Okay, so B vector is these directions, so minus B vector is along this direction. This is OB vector and this is your OB1. And one thing you have to know, the magnitude of OB vector and the magnitude of OB1 vector is equal to your small b, right? And see, if this angle is your theta, so what is the angle that is equal to this angle is your what? 180 degree minus theta, right? So if you draw, just see, if you draw this one, this is the parallelogram. So A vector and minus B vector. So resultant of the two vector is, just see here, resultant of the two vector is your R prime vector, which will be acting along OD. So this is, I can write here from the triangle OAD, I can easily write what? A vector or OA vector plus AD vector. So this is your AD vector, and AD vector and OB1 vector is equal vector. So I am writing OA vector plus AD vector is equal to OD vector, right? And see, OA vector means what? A vector plus AD vector means what? OB1 vector equal vector. So that is what? Minus B vector, and OD is equal to R prime vector. So you can easily write R prime vector is equal to vector A minus vector B. So these things you can easily write. R prime vector is equal to this one, right? So this is the subtraction of the two vector. And see, if you want to find out the magnitude of R prime, that is equal to what? A square plus B square plus 2AB. What is the angle between them? 180 minus theta. So you can write here cos 180 degree minus theta, to square root of this one. So you can write here A square plus B square cos 180 minus theta. This becomes minus cos theta. So you can write here 2 minus 2AB cos theta. So this is the magnitude of R prime vector. And if this R prime is making angle, suppose for example this angle is what I am considering, that phi. Phi is the angle making. So I can write here tan phi is equal to, what is the value of the tan phi? So the tan phi is equal to, you can easily write what? B sine theta. So see here B sine theta, but theta means what? 180 minus theta. So I can write here 180 degree minus theta divided by A plus B cos 180 degree minus theta. So this is equal to your B. This is second quadrant side is equal to positive. So I can write B sine theta, but in second quadrant cos is negative. So A minus B cos theta. So tan phi is equal to this one. Okay. So this is your subtraction of the two vectors. Now, next I am considering what? Next I am considering unit vector. Okay. Next I am considering the unit vector. Unit vector. In the case of vector algebra, next I am considering what? Next I am considering the unit vector. Unit vector. What do you mean by the unit vector? What is this unit vector? For example, here this is the vector, and I am considering this is your O is initial point, A is terminal point or head. So this vector is denoted by A vector, right? A vector. And see, unit vector means what? Whose magnitude is 1. Whose magnitude is 1. And you know it in from class 11th level. So unit vector magnitude is equal to 1. So if any vector is divided by its magnitude, then we can say it what? Unit vector. So unit vector is represented by this cap, A cap. So A cap I am writing. So vector can be represented. Vector can be represented, A vector can be represented, that is equal to magnitude of A into this A cap. And this magnitude of A, if you write here A is what? Magnitude of the A vector. So see, vector can be represented, this is the vector, A vector can be represented, this part is your magnitude part, this is your magnitude part, magnitude of the vector, magnitude, and this part is your direction. This part is your direction part. Okay, so this is magnitude part, this is the direction. So vector can be represented by this way, and this A cap is known as the unit vector. Okay, and its magnitude is equal to what? 1. How? It is very simple. The magnitude of the unit vector is equal to, from here I can easily write denominator is equal to magnitude of A, and you are want to finding out its magnitude, this is equal to 1. Okay, so magnitude of the unit vector is equal to 1. Next we are considering which things? Next we are considering that representation of the vector or representation